Hello, challengers. We are here in another weekly live that happens every Tuesday at 10 p.m. London time. And today we're going to be talking about a very important topic, which is how to learn technologies faster. I know that most developers nowadays, they learn in the wrong way. Nowadays there is so much content on the internet. It's difficult to filter. And I see many developers going through the tutorial hell. They start watching so many tutorials. They don't put anything in practice. They create an illusion that they are learning, but they're actually not. So today I'm going to be talking about this very important concept of deliberate practice. And this is the concept that the champions in the world use to be the best in the world. Obviously, you don't need to use to that level, right? You can use this same technique to achieve your career goals. And then if you want, obviously, to achieve the highest levels, you can still use the deliberate practice technique. But, it's important that we go step by step because, to reach the highest levels, it takes years, right? So let's explore here some techniques, this crucial technique of deliberate practice so that you learn technical knowledge in a more efficient way and you don't waste your time. Okay, now you might be wondering, okay, Rafael, what is deliberate practice? So if you never heard about this concept, it's basically a way to structure your learning with specific goals so that you improve your performance beyond your current ability level. It requires full concentration, and it also requires immediate feedback so that you know if you did it good or not. And there's a distinction between the normal learning and deliberate practice. So you have to keep in mind that deliberate practice is not just repetition, like random repetition. It's actually putting in practice, like you have to practice something that is uncomfortable. Or in other words, have to practice your weaknesses. So let's suppose, for example, that you are not very good with algorithms. You're not very good with graphs or whatever the data structure. So the technique of deliberate practice kind of force yourself to master this specific technique. It could be the technique of, sliding window or any other algorithm technique, or you solve many algorithms using graphs, for example, and then inevitably you're going to get better with this structure, right? So what are the core principles? So to do deliberate practice, you need to have well-defined specific goals. So you have to have micro objectives, right? So saying that, I'm going to become better with Java doesn't help us with anything, right? Instead of saying, I'm going to become better with Java, you could set goals, for example, about mastering polymorphism or mastering computable future or mastering the optimization of the garbage collection for high throughput applications. So you have to break it down in something that makes sense. Otherwise, get better with Java. Like how many years it will take that, right? If you don't know exactly what is the skill, it will take years, right? It has to be measurable. So like it could say, reduce response time by 40% or refactor legacy code to achieve 90% task coverage. So you have to find a way to measure your learning. Otherwise, there's no way to know if you're advancing or not. So find a way to figure out if you're making progress or not. And it has to have progressive difficulty, because if you are on your comfort zone learning the same thing, you're not actually growing, right? So you can start with thread local variables, and then you can advance to fork join framework, and then you can tackle complex concurrency data structures. So basically you progress difficulty until you learn more and more useful techniques for you. And the other technique you can use is intense focus and concentration. So on this one, you do deep work sessions, like something around 60 to 90-minute blocks. And obviously you can't check social media, Slack Overflow. So keep your phone in the focus mode. And like once you are in the flow state, you're gonna finish your tasks more quickly. And you need also to dedicate your time in a single task. So focus on one concept at a time. So for example, when you're learning like Spring Security, you don't want to learn like reactive programming or React or whatever the other technology. So you need to focus on one thing so that you master that specific technique. If it feels easy, you're not doing deliberate practice. So you need to struggle. Basically, you need to go through struggle to learn something new. Otherwise, you're not learning anything new. So you need to feel uncomfortable and you need to repeat that technique that you are struggling with until you master this technique, not in your conscious level, but on your subconscious level. Because if you don't know, 80% of our brain power comes from the subconscious mind, right? So the conscious mind is only 20%. And if you are solving your problems with your subconscious mind, then you have a lot more power, right? You can solve an algorithm problem, for example, a lot more quickly. And you need to get immediate feedback loops. So, for example, you can write a test and see if the test passes or not. You can have also code reviews with friends, and you can use tools like SonarQube, and you can also use performance profiling like JProfiler or Async Profiler, and real-time feedback. You can also get real-time feedback by doing pair programming, right? And you need also to repeat. So you need to endure boredom, and that's normal. So for example, if you want to master graphs and you're not really good with that, so you're gonna need to implement traversal algorithms of graphs many times up to the point that it gets boring, right? And you need to embrace boredom and to do the work you plan to do, even if you don't feel like it, even if you feel bored. And that's one of the challenges we need to face when we are learning something new. And if you really want to get really good on those techniques, you need to face boredom. So you can do repetition in a kata style exercises. So you can, for example, if you want to master design patterns, you can implement design patterns in different contexts. And like if you want to learn about refactoring, you take the same code base and refactor it multiple times. And you could use, for example, you could refactor the code for monolith, microservices, and event-driven design. And for algorithms, you can implement the same algorithm using different approaches. So, well, I actually recommend you to solve the easy and the medium algorithms in whatever platform you prefer. And then by practicing those concepts, you're going to get better and better. But if you do that intensively, it won't help you much. I will talk more about that. But basically, in a few words, consistency matters a lot more than intensity. So you have to keep that, you have to remember that, because that makes a huge difference, right? Okay, and how do you master the Java technologies? So firstly, we should start from the fundamental skills, right? So what would be that? So firstly, computer science fundamentals. So data structures, right? What I'm talking about arrays, linked lists, trees, graphs, hash tables, understand time space complexity trade-offs, algorithm design, so mastering sorting algorithms, search techniques, graph traversals such as BFS and DFS, dynamic programming patterns, and complexity analysis. For example, practice calculating big O notation, memory management concepts. So basically, I mean to understand the difference between stack and heap, right? And some JVM specific implementation concepts. And regarding system fundamentals, it's important to understand about operation system concepts such as process versus threads, context switching, scheduling algorithms, deadlocks, and you can write simple code to simulate those scenarios. Network programming basics. So, we need to know at least the basics of, network. And I mean by that TCP, IP, stack, HTTP protocol, socket programming. So you can build something very simple and see those concepts in practice. Database fundamentals. So ACID properties, normalization, indexing strategies, query optimization basics, computer architecture, CPU caching, memory hierarchy, branch prediction. And regarding programming paradigms, obviously object-oriented programming, and you can practice modeling real-world projects, and you can even create a pet project for that. Functional programming, you need to master immutability, pure functions, higher order functions, map, filter, produce patterns. Procedural programming, so you need to understand structured programming, modular design, separation of concerns. And regarding software engineering basics, you need to master version control, right? So Git, for example, testing fundamentals, test spiral concept, unit testing versus integration and end-to-end testing. So mock stubs, spies, debugging techniques to find errors and find bugs, code reading skills. That's one of the most important skills for any software developer, because most of the time we're going to be reading code. Okay, so those are basically the main fundamentals we should know as software developers. And what are the application areas for Java developers? So we need to practice JVM internals, right? So we need to practice memory leak detection, analyze heap dumps, tune garbage collector algorithms, understand just-in-time compilation patterns, concurrency expertise. So we need to know about synchronized blocks, lock API, and lock-free algorithms using atomic references and var handles. Framework deep dives. Don't just use Spring Boot. It's important that you understand the auto configuration mechanism so that you create custom starters. And also it's important to master the application context lifecycle. Design pattern as well, so understand them. Solid principles. It's very important to understand them because you can create a much better code if you really master them. Clean code, so you can rewrite the same functionality multiple times, and you can improve naming, you can reduce complexity, you can enhance readability. Regarding performance optimization, you can use profiling practice so that you can identify bottlenecks, CPU, hotspots, memory, and you can do benchmark development. You can create JMH benchmarks for critical code paths. And database query optimization, you can analyze execution plans, practice index design, understand N+1 problems and their solutions in JPA Hibernate, and practical implementation strategies. So how can you learn faster? So it scientifically proves that it's a lot better. You learn a lot more if you learn something consistently instead of with high intensity. So you need to dedicate 25 minutes daily to do algorithms problem. And then you gradually increase difficulty. And for example, you go from array to dynamic programming, then linked list, then you can do an algorithm with graphs. And then bit by bit, you are improving your skills. System design study, you can do a weekly 2-hour study session with distributed systems, papers, and you can implement like those systems they do in an interview. Like you can implement a simple Instagram, or you can implement a simple Netflix, like simulating a real interview. And you can do low-level experiments. So maybe you can implement monthly projects, right? And you can write like a simple garbage collector or thread pool or cache, anything to practice your fundamental knowledge and create your practice environment. So you can create a sandbox environment using Docker, and you can have your databases, you can have everything you need, and you can solve problems on LeetCode or HackerRank. You can start with the easy ones, and then you can go to the medium problems. And it's also important that you document your learning journey, right? And potentially you can even share your knowledge, right? You can write an article explaining whatever you learn, and that helps you to solidify the knowledge. And time management. So it's important that you practice your whatever is the skill you want to master, right? It should be the first thing you do in the day, because like if you do this practice in the night, you're going to be very tired, and it might be very difficult for you to take action. Sometimes we feel so tired that we don't even do whatever we plan to do. And like if you need to do a deep dive, you can reserve a 4-hour block for complex topics, and then you can solve very complicated problems. And if you need to learn something very quickly, it's okay to learn to do those deep dives and, like focus, like create some time blocks where you're going to focus and you're going to learn those techniques. You can also create code review clubs so developers can review each other's code, right? And you can also be an open source contributor, and that's a great way to practice and get better, right? And you can also document your learning through technical blogging, and that helps you to solidify your knowledge and also helps in your visibility. It helps you to get jobs more quickly because you're going to be demonstrating that you really have the knowledge, right? And now you might be wondering, okay, so how many hours I need to practice that, Rafael? So how many hours I should practice to become a really good software engineer? So the good news is that if you do deliberate practice, you don't need necessarily to study or to dedicate 10,000 hours, right? And obviously it depends on the skill you want to learn. So here we are talking about becoming a full and, an expert software engineer. We are not talking about, to master algorithms in 3,000 hours. Obviously not. Like it takes fewer hours to master algorithms or system design. But what I mean here is that if you do deliberate practice and if you practice the things you need to solve problems, like to become a senior software engineer, become really, really good, like 3,000 or 5,000 hours would be enough, right? And this is not difficult to achieve. If you work in your day-to-day job, it's like you're going to practice many hours already, right? So, okay, let's continue. And what are the common pitfalls to avoid? So most developers fall into those pitfalls. And so many developers, they jump straight away to frameworks and they don't understand the underlying concepts. And then like they use Spring and they have no idea why they are using it. And they're just using it. They just memorized how to use it. But, when you see their code is poor. They don't know what's going on. And one possible solution is, to check the source code of Spring and understand what's going on behind the scenes. So maybe, you can even read Spring code. You can put the code from Spring on AI and have a chat with AI on what's going on there, right? And need to understand what is the problem that the framework is really solving. If you don't understand that, you're just using framework and you have no idea why you're doing that, then it's the wrong approach. And this is very common. Most developers are here in the comfort zone trap. So they repeatedly do the same thing. They do CRUDs that are very easy. They don't challenge themselves and they think that they're getting better, but they are not. They're just, stuck in their skills. So the solution is that you choose unfamiliar territories. You choose unfamiliar skills to improve. So for example, if you're very bad with algorithms, practice algorithms, become a better software engineer. Like creating CRUD won't make you a better software engineer, right? What will make you better is to solve, difficult problems, to solve complex problems, is to create personal projects, is to use technologies you never used in your life, use technologies that are relevant to the market, do problems with system design, to like designing a system yourself, your own system. So all of those things will make you a better software engineer. Tutorial hell, that's another common trap. Many developers are here. So basically, they go to YouTube, they watch all the videos they can possibly watch. They go to Udemy, they buy all the courses, and they passively consume content without active practice. So they're just creating illusion. They're not learning anything. They're not building real skills. For every hour you're reading or watching, and I'm not saying that courses don't work, because they do work. The problem is that most developers, they just watch, they don't take any action. So it's important that you take action, you create code, you do something, right? So that you really acquire a skill, you don't learn something passively, right? And lack of reflection. So you basically move to the next topic without consolidating the learning. So like, how can you do to consolidate the learning? You can document your learning. So I recommend writing articles. And I know that many developers, they are afraid of criticism, but really in the beginning, nobody cares. Basically, when you're starting, very few people will read your article. That's the truth. So you need to get some consistency until you get some traction, right? And the other thing that you have to accept that is your article won't be very good in the beginning, and that's okay. So you just need to think, okay, like my objective is just to consolidate my knowledge. So I don't really care if people don't like about my article. So this mindset is a lot more powerful because, your only goal is to learn, right? Obviously, with time, your article will improve, but the point is that you're learning. It's not about getting validation from other people. It's about your learning and your career growth, right? And you need to practice with purpose, right? Random coding without specific improvement goals will lead you to nowhere. So you need to have a specific target. So if you have someone to do code reviews for you, that really helps. Or maybe you can do interviews with a developer friend. And by the way, in the Challenger Developer Mentorship, you can do that. You can do interviews with my other mentees, and that's great. And, but here, basically, you need to focus on your weaknesses so that you improve more quickly. So you should be out of your comfort zone and get feedback quickly. So the faster you get feedback, the faster you grow, because we have lots of blind spots and there are many things we don't know what we should improve, right? So, and measure progress as well. So how can you do that? So fundamental skills metrics. So you can solve, I wouldn't say hard. You don't need to solve the hard ones. So you need to have the ability to solve easy and medium algorithms on LeetCode or HackerRank, and system understanding. You can explain and diagram how requests flow through a multi-tier application, right? Debugging speed, time to identify root cause in unfamiliar code bases, objective metrics. So you can get feedback from other developers, and another metric is your problem solving speed. So you can time yourself to solve problems and then improve bit by bit. And one very easy way to time yourself is to use Pomodoro. And I use Pomodoro all the time. So this is very useful to me. That helps me to know exactly how many hours I've been dedicating to my objectives. And this is useful because if you know how many hours you are dedicating to solve your problems, and so you can be more strategic. So for example, if you feel that you need more practice in a specific skill, you can increase the hours you're going to dedicate to that. And regarding complexity handling, so skill production indicators, basically the more you practice, you're going to have the ability to work with increasingly complex code bases without feeling overwhelmed. And the more experience you get, the better quality technical design documents and system design proposals you're going to be able to do. And it's also important that you practice your skill of knowledge transfer. So, For example, you can improve your mentoring effectiveness, which is basically to successfully explain complex concepts to junior developers or intermediate or senior, depending on the topic you're talking about. Technical writing. So the more you write, the more you improve your communication skills, because this is a meta skill. So communication is what? Communication is basically your ability to organize your ideas and to pass this message. It doesn't matter if you're going to write or if you're going to speak. Basically, the more you write, the more you're able to organize your ideas. By writing, you're going to become a better speaker, because communication itself is your ability to organize ideas and to communicate in a clear way where other people can understand you, right? And after you do the deliberate practice, you can also check your interview performance, success rate in interviews, and that's a good way to measure your progress, right? So let's continue. And for long-term mastery, so this is a rough plan. Obviously, it's more complicated than that, but it's possible to reach like a good level as a software engineer with those ideas. So the phase one is about fundamentals, right? So you learn computer science fundamentals like data structures, algorithms, system basics, programming paradigms. Then you can practice like algorithm problems or cache key, or you can read classic computer science papers. Phase two, Java Foundation. You can learn the core Java basic patterns, and you can learn also testing, debugging, common frameworks. And on phase three, specialization. So you can get a deep expertise in distributed systems or performance or security, and how you can practice that. You can do complex system design. You can do open source contributions. It's a great way to practice your technical skills and also to gain visibility in your career. And phase four is about mastery and innovation. So the focus is cross-domain expertise, right? So that you are able to make high quality technical architectural decisions. You can also practice building frameworks, libraries. You can do even speaking if you feel like doing it, or you can mentor other developers. And that's a great skill to have as a senior software engineer. Fundamental to advanced practice examples. So like if you want to improve with algorithm, like obviously you don't need to follow this plan. You can create your own plan, but this is just an example, right? So could be like implement sorting algorithms daily, and then you analyze their complexity, and like you can, let me just fix that here. And then from week 5 to week 8, you can build a thread safe data structures from scratch, and you can understand synchronization primitives. From week 9 to week 12, you can implement design patterns in Java, compare with language specific idioms. And from week 13 to week 16, you can profile and optimize your applications, correlate improvements with fundamental knowledge. And then you can connect fundamentals to Java mastering. For example, you can go from arrays to collections, and you can master array manipulation, understand array list, optimize collection usage. So because, for example, an array list behind the scenes is actually an array, right? An array of objects. And then you can go from recursion to functional, and you can master recursive thinking, understand stacked frames, stream API. Then you can go from pointers to references, understand memory addressing, and you can go from processes to JVM. You can understand operation system processes, right? So there are many things you can master in the Java programming language. And the other thing that it's very important to show you, so it's this. So this is the difference of daily practice to long, intense practice. So on week 1, so this is the difference between practicing 25 minutes a day from Monday to Sunday, other than practicing a skill 10 hours a day. So look at the difference. If you practice a skill 25 minutes a day, look at how much more you learn. So you have exponential growth, as you can see. And if you learn something like 10 hours in a Saturday, It's 10 hours. It's even more. Look at how slow is your growth. So this is the orange line is how much you learn if you study something for 10 hours a week. And the blue line is how much you learn if you do deliberate practice and you're practicing 25 minutes a day. Look at the difference. You save a lot of time and you learn a lot faster. So why is that? It's because if we practice something like daily, we also help ourselves with our long-term memory, with our long-term mastery, right? And we also take advantage of our sleep because neuroscientists found out that we really learn something when we sleep. And that's very interesting, right? So that's another reason why practicing daily, you absorb a lot more information, right? Because if you practice something for 10 hours in a row, you get exhausted. And like at a certain point, your brain will just reject the information. That's a reason why practicing those skills daily for 25 minutes, you learn a lot more. And you can use Pomodoro technique for that, right? And you can learn a lot faster. So the difference is just ridiculous. It's just insane. And it's insane how much time you save as well, right? So today we talked about deliberate practice, and I explained the central concept of deliberate practice. So, which is basically to practice something that you feel uncomfortable with, and something also strategic for your goals, for your career goals, and for your growth. And we explored here some of the concepts we should be practicing for Java mastery and for fundamentals, practical implementation strategies. So we discussed about sharing your knowledge, also about contributing to open source projects. We talked about how many hours we should do in average. Obviously, it depends from people to people, but in average, if you implement 3,000 or 5,000 hours of deliberate practice, you become a top-notch software engineer, right? We talked about some pitfalls. So some developers, they go through the tutorial hell and they don't practice properly. Therefore, they don't improve any skill and they become stuck. They can't get better jobs. They're not becoming better software engineers, and they're just creating an illusion that they are studying and becoming better, but they're actually not. So we talked about some ways to measure progress. So which could be by having feedback from someone or by really doing real world interviews and checking out how you're doing. We talked about long-term mastery. So we talked about some paths, right? Obviously, it depends on your context, depends on what point you are on your career. This was here just an example. We talked about fundamentals to advanced concepts, and we also talked about the difference between consistency and intensity. And as you can see here in this graph, if you practice consistently, you grow a lot faster, even if you practice less time, right? Thank you so much for being here, and congratulations on focusing on your career, on being here on this Tuesday. It might be late for you, it might be early, I don't know exactly in what part of the world you are, but congratulations on watching until here. And I'll see you on the next Tuesday at 10 p.m. London time. And for you who is watching on YouTube, don't forget to subscribe the channel so that the channel gets bigger. And that's it. Thank you so much, guys. I'll see you the next time.